Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்கள். எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
So welcome student. Today we are going to discuss about the integration equation of first order reaction. Rate equation for first order reaction. Okay, so integrated rate equation for first order reaction. So first order reactions, it means the rate of the reaction only depends on the concentration of one reactant. Okay, one reactant. For example, the reaction is A gives P product. So in this reaction, the rate of the reaction only depends on the concentration of only one reactant. So this one we can written as like dt to k into, okay, so we can interchange. If we erase this minus, we have to put here. So then integration k dt. Okay, so the result is negative log of A, concentration of A gives K into T plus C. Okay, so this expression can be notified with T is equal to 0 at the time T is equal to 0, which means initial, the reaction or the experiment yet to start. So that time can be noted as T is equal to 0. That time the concentration of A will be A naught. Okay, the concentration of the reactant has to be taken as A naught. So here we can substitute this A naught. So ln or negative log of A naught is equal to T into minus K into 0 plus C. Okay, because here T is equal to 0, we have to introduce T is equal to 0. So then ln negative log of A naught is equal to C. So this expression, this one. So this expression has to be introduced in this equation. So substituted in equation 1. So negative or antilog of A is equal to minus K into T plus, what is the value of C? Antilog of A naught. Okay, we can take here KT is equal to minus, okay, so we can this antilog has to be changed in terms of logarithmic. So 2.303 and here we can in this step, 1 minute, we can written this step as K. So KT, this step also can be written as K into 2.303 T log A naught by E. Okay, so this is the integrated equation for first order rating. Okay, so K is equal to 2.303 divided by T into log of concentration of A naught divided by A. So A naught we can take, so this equation here I am writing. So A naught can be mentioned as A and A as A minus X. So this will be changing into 2.303 by T log of A by A minus X. So here we can write like this. So what is the unit for K? Per second, as we discussed earlier. So the unit of rate constant in first order reaction is per second. Okay, so for this reaction we can write the diagrammatic representation. So here we can take concentration, here rate. See, so the rate is depends on the concentration of reactant. So it has to be in positive slope, right? So the if the concentration increasing, then the rate must be increasing. So this one for relationship between A naught versus R. Okay. So another diagrammatic representation is, we can follow this one for this expression. Okay. So here if we take t, see the slope must be here y is equal to mx plus c. In this format we are obtained. So this is m. So the slope must be negative. Okay. The slope must be negative. Okay. So this one is A naught. Okay. And another one, we can express T of also. T of means we have to change this A as A naught. That one we can discuss in another video. So students, just understand, this is the rate equation for first order reaction. R is equal to K into rate constant into concentration of one reactant, that is A. So we can write this R in terms of change in concentration or average rate expression, minus dA by dt, which is equal to rate constant into concentration of A. So we can interchange, and taking integration will get antilog of A is equal to minus K into T plus C. So here at T is equal to 0, that means the reaction yet to start. Okay, that is initial time. T is equal to 0. The concentration of reactant must be as A naught. Okay, so we are putting this value into this equation number 1. So we can obtain negative log of A naught is equal to C. The concentration is equal to antilog of A naught. Okay, so again this value has to be substituted in equation number 1. So we can obtain this equation, K is equal to 2.303 divided by T into log of concentration of A naught divided by A. So this values has to be taken as some simplified in ratio. So that one A naught has to be taken as A, and A in terms of A minus X. So that implies the equation into K is equal to 2.303 divided by T log of A into A minus X. So the unit for this rate constant is per second. So for this equation and this antilog equation, we can get two diagrammatic representation. So and another one T of. Okay. So T of for first order reaction. Okay, here A has to be taken as A naught by 2. A naught by 2. Okay, so we have to put in that rate equation, integrated rate equation 3.303. So here we are finding T of na. So we have to take this side K here, log here A naught by 2. So which means we can get 2.303 divided by K log 1 by 2, which means log 2. Okay, which means log 2. So T of is equal to 2.303 divided by K into log 2. The value of log 2 is 0.310, which we can get 6.93 by K T of. This is T of value for first order reaction. Here we can draw a diagram. Okay, see concentration T of. Here the T of is not related to any concentrate terms. So that's why T of for first order reaction does not depend on the concentration of reactant. So which means T of will not vary in terms with initial concentration of reactant. So this is also very important diagrammatic representation. You must remember this one. Okay. So this is all about the first order reaction. Okay. So next we are going to discuss about further classes in this chemical kinetic chapter. Okay, thank you.